Hello everyone, I'm Kuya Romel. In this video is all about derives the formula for permutation of an object taken R at a time. Let's derive the formula for permutation.
So, for today's video, we're going to discuss the derives of the formula for finding the number of permutations of n objects taken R at a time. So, here are objectives for this video. First one is to derive the formula for finding the number of permutations of n objects taken R at a time. Then, solve problems involving permutations of an object taken R at a time. And the last one is to apply the concept of permutation of an object taken R at a time in a real-life situation. Permutations of an object taken R at a time is denoted by the symbols P, quantity n and R, and subscript n, capital P, and subscript R, where n is the total number of objects in a given set, R is the number of objects to arrange, and R is less than or equal to n. So, permutations of an object taken R at a time. So, if n is equals to R, then npr is equals to n factorial. So, if your n and R are equals, so the answer will be n factorial. So if R is equals to 0, then np0 is equals to 1. So if R is equals to 0, then your answer will be equal to 1. So if R is equals to 1, then the np1 is equals to n. So if your R is equals to 1, so your answer will be the value of your n. So, let's derive the formula for finding the permutation of an object taken R at a time. So, P quantity n and R multiplied by the P quantity n minus R. So it is equals to Pn, or the permutation of n. Then copy lang P quantity n and R multiply the P n minus R is equals to n factorial. So where does n factorial come from? It comes from the P multiplied by n. So permutation of n is equals to n factorial. So next step is P quantity n and R multiplied by the n minus R factorial. So n minus R factorial comes from the P permutation of n minus R. So, P quantity n minus R is equals to n minus R factorial. So it equals to n factorial. Just copy, then divide both sides by n minus R factorial for the P quantity n minus R to be remain in the left side. So the final formula is P quantity n and R is equals to n factorial over n minus R factorial. So that's our formula for finding the permutation of n object taken R at a time. So let's solve examples involving permutation of n object taken R at a time. In how many ways we can arrange 2 pencils from a set of 5 pencils? So let's determine what is n and what is R. So the formula is P quantity n and R is equals to n factorial over n minus R factorial. So what is our n? Yes, it's 5. Then what is our R? Then it's 2. So just substitute the value of our n and R to the formula. So P quantity 5 and 2 is equals to 5 factorial over 5 minus 2 quantity factorial. So let's solve the 5 minus 2. 5 minus 3 is equals to 3. Yes. Then 5 factorial over 3 factorial is also equivalent to 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Then, since there are common numbers, can we cancel it, class? Yes, we can cancel it since they are common. So we're going to cancel 3, 2, and 1. Then our final answer is equals to 20. So do you want another example? So yes, we're going to go to the example number 2. So you have 12 songs downloaded on your computer and you want to put 4 of them on the CD. How many different ways can you do this? So there are 12 songs down in your computer and you want to put 4 of them on the CD. Let's just analyze first the problem and determine what is our N and what is our R. So what is our N? So yes, the 12, and our R is equals to 4. So let's just substitute the value of N and R. So P quantity 12 and 4 is equals to 12 factorial over 12 minus 4 factorial. And then solve the 12 minus 4 is equals to 8. Then 12 factorial over 8 factorial is also equals to 12 times 11 times 10 times 9 times 8 over 8 factorial. So can you cancel out the 8 factorial, class? Yes, we can cancel out since they are common. Then it is equals to 12 times 11 times 10 times 9 is equals to 11,880. So let's solve another example for your better understanding. So evaluate the following expressions. So the 5p5. So what is our N? Our N is equals to 5 and our R is also equals to 5. So what is our answer? Based from the previous discussion. So since our N and R is equals, the answer will be N factorial. So 5 factorial is equals to 5 times 4 times 3 times 2 and times 1. So 5 times 4 times 3 times 2 times 1, 11. How many our answer is equals to 120. 5 factorial is equals to 120. So let's solve another problem. The 6p0. So our N is equals to 6 and our R is also equals to 0. So based from the rules, so our R is equals to 0 and our answer will be equal to 1. Yes, since our R is equals to 0, our answer will be equals to 1. Let's evaluate again the last problem. So 4p1. So according to the rules, our R is equals to 1. So copy the formula, then substitute. So n 4 factorial over 4 minus, so we're going to subtract first our denominator. So 4 factorial over 4 minus 1 is equals to 3 factorial. So 4 factorial over 3 factorial is equals to 4 times 3 times 2 times 1 and over 3 times 2 times 1. So can we cancel out the common numbers. Yes, we can cancel it out. So it is equals to 4. So in summary, the permutation of n object taken r at a time is equals to npr equals to n factorial over n minus r factorial. So this equation is used to find the permutation of n object taken r at a time. In a one-up crosswise, solve the following problems involving permutation of n object taken r at a time. Copy and answer the problem.